Hello, dear students. Today we have Proposition 14 of Book 2. To construct a square equal to a given rectilineal figure. To construct a square equal to a given rectilineal figure. There's the given rectilineal figure. It could be in whatever shape, but it's rectilineal. It can't be, for this one, it can't be curved, okay? Great, so thus it is required to construct a square equal to this given rectilineal figure. Now, let's make a parallelogram with a good color of green. If that's going to work. Let's make a parallelogram, a right angle parallelogram in this case. Remember, we can construct a parallelogram in a given angle equal to a given rectilineal figure. We've proven that. Let the given angle be a right angle. Therefore, the constructed parallelogram equal to the given rectilineal figure, it's going to be smaller than that. Something like that, just trying to make it look somewhat reasonable. So this is a parallelogram in this angle equal to this given rectilineal figure. We've proven we can do that. Now, if in so doing that we made a square, we're done. That's it. But if one of these sides is not equal, or they're not equal, then it's not a square. Now we need to construct a square. Let it be that. Let's say that we have to construct this square. Okay, so we're going to continue this straight line. And then we're going to cut it equal to this. Más o menos like that. And then we're going to take this whole line and we're going to cut it in half. We're going to bisect it. We know we can do that. We've proven that you can bisect the line. Okay? So now look at this line. It's been cut into equal parts. Let's go like this to make it more interesting. It's been cut into equal parts and unequal parts. Wait, let's go. Equal and unequal. Okay? And this would be the line between the points of section. Remember, we showed in the past that if a line be cut into equal parts, I'm going to make this a little bit obviously equal, easy to see, equal parts and unequal parts, the rectangle contained by the unequal parts, this and this, is plus the square on the line between the points of section, right here. Remember the cut between the points of cuts. So the rectangle contained by the unequal parts and the square on the line between the points of section is going to be equal to the square on the half. Great. Now let's do something. Let's make a circle here holding this fixed. Okay, so we're going to make a circle. Boom. So obviously then this, let's just make it a half circle for now and kind of continue it around imaginatively, like this. Okay. Now let's continue this line here until it cuts the rest of the circle, say. And let's connect these 2 points. Good. Now, because this is equal to this, the square on this is equal to the square on this, okay? But remember, we know that because this line has been cut into equal and unequal parts, the rectangle contained by the unequal parts plus the square on the line between the points of section is equal to the square on the half, but this is equal to the square on the half. So now we can say that the rectangle contained by this line and this line plus the square on this line is equal to the square on this line. But look, this is a right angle triangle because we drew this right angles from our what's that called? Our right angle parallelogram, our rectangle, okay? So this is right angle. So this is a right angle triangle. The square on the hypotenuse, therefore, is equal to the squares on the sides. The square on this is equal to the square on this and the square on this. But the square on this was proven equal to the rectangle contained by this plus the square on this. So now we know that the rectangle contained by this and this plus the square on this is equal to the square on this and the square on this, because the square on this and the square on this are equal to the square on this. But look, we have the square on this on both sides. Therefore, the rectangle, let's take them both out, but out of both sides, equals subtracted from equals, the remainders are equal. Therefore, the rectangle contained by this and this is equal to the square on this. But the rectangle contained by this and this is this rectangle because this side is equal to this side. This was cut equal to that. So the square on this is equal to this rectangle. But this rectangle was proven equal to this given rectilineal figure. Therefore, the square on this is equal to the given rectilineal figure. Quod erat demonstrandum. It was required to, given a rectilineal figure, to construct a square equal to it. Okay? So we know we can do that. Quod erat demonstrandum. Given a rectilinear figure, to construct a square equal to it. You do it by making your rectilineal your rectangle, and if it's a rectangle, it's a square, you're done. If it's not a square, then you do what we did, and you have your square. Thank you. Bye.